So I'm going to refer to the typed notes here because it doesn't make sense for me to write this again. All right, we're looking at the definitions for injection, surjection, and bijection. So an injection is if every element in B is mapped from at most one element from A. So we can still have extra elements in our codomain that are not part of our range, but every element from A has only one arrow connecting it to B. We also call this a one-to-one function. The way we test injection is if f of x1 is equal to f of x2, then x1 has to be equal to x2. All right, so that's injection. So let's come and look at, let's look at our examples. So we're testing here injection, surjection, bijection. So let's start with injection. Yeah. So we've got A is 1, 2, 3, 4, and B is what we're mapping to, 5, 6, 7, 8, 9. F of x is equal to x plus 4. So let's test out our injection. One way that we could do this is by making our mapping diagram. So we've got A, 1, 2, 3, 4, and then we're mapping over to B, x plus 4. So 1 plus 4 is going to be 5, 2 plus 4 is 6, 3 plus 4 is 7, 4 is 8. Let's make sure these are in here, 5, 6, 7, 8, and then there's also 9. So we map over. So every element in B is mapped by at least 1 in A. Yes, this is an injection. So that is true. Let's look at B. We're going from real positive to real positive. F of x is equal to root x. So let's test this one by looking at f of x1 is going to be the square root of x1. F of x2 is going to be equal to the square root of x2. Well, root x1 is equal to root x2 only when x1 equals x2. That's true, so this is also an injection. Okay. Let's look at C. We're going from real to real. F is the pairs x and x squared, so this is like saying f of x equals x squared. So doing the same thing, f of x1 is x1 squared. F of x2 is x2 squared. x1 squared is equal to x2 squared. Well, this happens if x1 is plus or minus x2. So single elements would map over to two different elements. This is not an injection. We've got two elements here, so not an injection. All right, let's look at surjection. We have surjection when each element in B is mapped by at least one element in A. Yeah. So the range is equal to the codomain. So there's no extra elements. Elements from A can have more than one arrow connecting it to elements in B. No problem. That's okay. But every element in B has to be mapped by something in A. So let's look over here. We've got 9. I'm going to do this. So 9 is not mapped, so this is not a surjection. Okay. If I think about my range and my codomain is all real numbers. If f of x is equal to the square root of x, well, given that I'm putting in all reals, eventually I will also map to all of the square roots. Yeah? Every positive square root can be given by finding the square root of a positive real. That's true. So this is also going to be a surjection. So all values of positive reals can be found with the square root of positive reals. So this is a surjection. Bijection is when you're both. Yeah? So this is also a bijection. All right, thinking over here with surjection, we're mapping from reals to reals, but f of x is equal to x squared. The output of x squared is only positive reals. Yeah? So that means that the range does not equal the codomain. So range not equal codomain, so not a surjection. All right, so let's go back to the idea of surjection and bijection. The way that we can officially test this, for every b, there must be an a such that f of a is equal to b. So that's a way to officially test it. If we have elements from A that map to more than one in B, we call that a many-to-one correspondence. No problem. Sorry. If we have several elements in A that map to a single element in B, that's no problem. Yeah? Many-to-one. And then bijection, it's injection and surjection. Each element in A will be mapped by exactly one in, each element in B is mapped by exactly one in A. We call this one-to-one correspondence as opposed to one-to-one function. So one-to-one correspondence. And normally we test by finding first injection, then surjection. So that's injection, surjection, bijection.